Hello, and welcome to our second example for spring potential energy for grade 12 physics. Now, we talked about this a little bit in the last video, but the idea is a spring will store energy in it while it is compressed or stretched. When I have that spring compressed or stretched, that energy can then be turned into kinetic energy or possibly other types of energy, but kinetic energy is the one we're usually looking at and usually interested in. So let's take a look at this example. In this case, I've got two carts connected by a spring. So I've got a distance here of a spring, or a length of a spring, compressing the spring to this length here. Spring constant is, or K is 200 newtons per meter, so we've got that already. And what is the elastic potential energy stored in the spring? So let's start by writing down what we know. Well, I'm going to start over here. My spring potential energy is K, and that is going to be 200 newtons per meter. All right. Well, I'm looking for my elastic potential energy. So I'm looking for my potential energy stored in a spring. And notice that I have two lengths here. When I'm looking at my formula for spring potential energy, this is 1/2 kx squared. And notice that this here, that k or that x value is the compression or stretch. Okay. It actually doesn't care whether it's compression or stretch. Hooke's law doesn't care whether the spring is compressed or stretched. It works the same way. So my x value here is my compression or the stretch, but I don't have that. So I need to figure that out. So what I've got here is my compression. I can figure out by going, well, it started at 0.5 meters and it ended at 0.25 meters. So I actually compressed 0.25 meters. So there's my x value that I need. Be careful with this one when it's looking for it. You're looking for the compression or the stretch. This compressed by 0.25 meters. Now, all it asks for is my potential energy stored in the spring. My potential energy stored in the spring is 1/2 kx squared. And that works out to 1/2 times 200 times 0.25 squared. And when you work that out, your potential energy stored in the spring works out to 6.25 joules. So there's my final answer. This is a nice, easy one. The only trick with this one is that you have to figure out the compression instead of just it being given to you in the question. Now, again, remember that in this case, I just found my potential energy in the spring, but I can convert that into kinetic energy depending on the question. I could say, hey, how fast were these carts going? Well, I don't have enough information in this one because I don't have any masses of them or anything like that, but I could figure that out if I had masses. And then from my kinetic energy, this might be turned into other forms as well. So if this is launching a projectile up, I could figure out how high the projectile would go by figuring out my potential energy due to gravity, because that would be the same thing. I hope this has been helpful. This has been a short little video on spring potential energy. Have a great day.